Hello, Internet. Today we're diving into the world of noise, an essential technique behind dynamic textures in TouchDesigner and computer graphics. Welcome back to the TouchDesigner 101 series. This time, we'll be exploring one of the most essential concepts for creating textures, movement, dynamic changes, and simulations: noise. Let's break down this video. 1. Understanding noise in computer graphics. 2nd, simple noise texture. 3. Displacing geometry with noise. 4th, procedural animation with noise. 5. Simulating natural phenomena, clouds, water, and fire. Chapter 1. Understanding noise in computer graphics. Noise, a fundamental tool in computer graphics, was developed to simulate natural phenomena like clouds, terrains, and water. A major breakthrough occurred in 1983 with Ken Perlin's development of Perlin noise, which became essential for procedural texture generation. This type of noise introduces controlled randomness through pseudo-random values, allowing for the creation of patterns that are both organic and structured. But what are pseudo-random values? These are numbers that appear random but are generated by a deterministic process. Unlike true randomness, which is entirely unpredictable, pseudo-random values are produced by algorithms that, given the same initial conditions, will always generate the same sequence of numbers. On the other hand, true random values come from physical phenomena, often found in natural processes such as radioactive decay, thermal noise in electronics, or atmospheric noise. These processes are inherently chaotic and not influenced by previous outcomes. In TouchDesigner, noise has countless applications, but there's not a strong need to simulate natural phenomena as you might in Unreal Engine. What makes TouchDesigner powerful is its ability to help us create unique, unpredictable universes and languages that go beyond reality. While you can simulate water, terrain, or clouds, the real value of TouchDesigner lies in exploring and crafting something entirely unexpected. Chapter 2. The Noise Operator in TouchDesigner. Let's begin by dissecting the parameters of this operator to gain a deeper understanding of how each one will affect what we do later on. Type selects the type of noise to generate. Like Simplex 3D, an efficient algorithm for creating smooth, continuous textures on the GPU. Seed sets the initial point for noise generation. Changing this value creates different noise patterns, but the same seed will always produce the same pattern. Period controls the scale of the noise pattern, with higher values creating broader, smoother textures, and lower values producing more detailed noise. Harmonics adds layers of noise at different frequencies to increase the complexity of the pattern, creating richer and more detailed textures. Harmonic spread adjusts the distribution of harmonic frequencies, allowing for more varied and less uniform noise patterns. Harmonic gain controls the intensity of each harmonic layer, affecting the contrast and prominence of the noise in the overall pattern. Exponent modifies the distribution of noise values, allowing you to adjust the contrast and dynamic range of the pattern. Amplitude defines the maximum intensity of variations in the noise, determining how pronounced the generated textures are. Offset shifts the range of noise values, adjusting the overall brightness of the pattern without changing its structure. Monochrome generates noise in grayscale, or in color if disabled, allowing for more complex and colorful patterns. Aspect correct maintains the proportion of the noise pattern when changing resolution, preventing distortion in the texture. Before moving on, I've created an interactive mind map that provides a comprehensive list of details about the noise top in TouchDesigner. This resource is highly useful for educational purposes or for those who are just starting out. Access to this material is completely free, and I'll include the link in the description. Chapter 3. Creating a basic 2D texture. Let's create what will be our starting point for the rest of the chapters, where we'll get more familiar with the practical use of the noise operator. Before we dive in, let me explain a bit about what we're doing. Essentially, we're working with a noise that has colors enabled, with the monochrome option turned off. I've adjusted the colors because I want to achieve a specific look with these vibrant turquoise and pink tones. However, I also want the front color, which is almost yellow, to have more presence. So I'm using the same noise, but I've added a level to convert it to black and white. Then, with some post-processing, I enhance the saturation in just this part of the color spectrum, which I'll later blend into the overall composition. So let's dive into the network setup. We'll start by creating a noise operator and connecting it to a level like this. Next, we'll duplicate this operator and create a constant below the level, placing it right here. We'll then connect these using a composite, positioning it like this and linking everything together as follows. After the composite, we'll add another level following, that will create another composite to merge these two operators. Next, we'll create a level top, position it here, and then add a transform because we'll need to make some adjustments later. We'll also create another constant and place it here, linking these two together with a composite that we'll keep over here. Finally, we'll add an out to get the final result perfect. Now select all the operators, go to the Common tab, and use the Parent Panel Size option to ensure everything scales correctly. As you know, I prefer working in this specific resolution, especially when working vertically. You can also split the screen into two views. Select the top view on one side and drag the final top over here. Now, if you find it distracting to have it here, as I often do, you can move it. We'll pull this out, place it over here, and then drag this into position. With that done, let's turn it on. And now we have our noise visible on this side. We can now move on to the next step, which is parameterizing this setup. So head over to the noise and apply the following parameters. Perfect. Let's turn off the monochrome option because we want this noise to be colorful. Next, go to the level here. This is a bit subjective, but I'm aiming for a very specific look, so I'll use the following color values. Now we have these turquoise tones, which are exactly what I was going for. Moving on to the second level, the only adjustment we'll make is going to the Common tab and selecting the 32-bit mono option, because I want this one to be black and white. Finally, let's select this color for the constant. And in the composite, I'll choose the multiply blend mode. We'll reverse these two layers, and in the level, I'll adjust the settings to retain the most saturation for this color here. So, in the level, I'll use these values. Now, I have the maximum saturation for this color, which is what I need. Let's go back to the composite, and here's where it gets interesting. We'll use the add mode to blend everything together. Now I'm really close to what I need. In the final level, we can tweak some values as part of the post process. For now, I'm satisfied with it, so I'll leave it as is. Let's move on to the transform, where the only change I'll make is to set the scale to 0.9 by 0.9. And in this constant, I'll set the color to black. Then, in the composite, we'll choose the over option as the blend mode, and here we have our noise with this black frame. I want this frame to be a bit more symmetrical, so I'll set it to 0.95 and that's it. Perfect. Lastly, let's go to the Noises Transform tab and use the expression abs time divided by 15 to add animation to the noise. Perfect. Now we're going to use this same noise in the following chapters so that you can understand the possibilities and applications we can achieve with just a single noise. Retro moment. The concept of noise in graphics was popularized by Ken Perlin in the 1980s, who developed the Perlin noise algorithm. Perlin noise became a fundamental tool for creating natural-looking textures in CGI and is still widely used today. Chapter 4. Displacing geometry. Using noise to displace a geometry creates intricate and organic shapes. We'll demonstrate this by applying a noise texture to a grid. Let's do a quick review of what we'll be doing next to achieve the displacement effect. Here we have the simple 2D texture we created earlier. Remember, you can play around with the parameters to get the composition you want. In the next section, we'll create the materials that will be referenced in the PBR material. The most important map is the height map, as we'll use it to create the displacement effect with a Grid SOP later. Finally, we'll move on to composing the 3D scene. This follows the usual approach: a camera, a light, an environment light, and finally, the render. We'll finish everything with post-processing. We're going to apply ambient occlusion, and as always, the RGB key to get the black background. This part, honestly, I won't be showing in this tutorial, but if you want this project file, you can find it on my Patreon. What I'm doing here is just setting up a grid to have this kind of three-dimensional visualization. The step one, by creating a null operator after this composite top. To keep things organized, I like to use this method to apply the maps. So we create a null here, and then create another null Let's select both nulls and duplicate them 4 times. Perfect. In the third null, we're going to insert a level operator. In the fourth null, we'll insert another level. Finally, in the last null that we create in this row, we'll add a normal map. Perfect. Lastly, let's rename these as follows. These will be the maps we'll later use in our material. Let's move on to the next part of the 3D scene. We'll create a grid operator here. Next, let's create attributes. The attributes will allow us to use displacement, so it's super important. After this, we'll create a material. For the material, we're going to drag a PBR operator into the material top. Perfect. Then, the classic components to set up a 3D scene. Add a geo, an environment light, and for the environment light, we'll insert a movie file in and drag it to the environment light. After that, we'll create a light operator and place it here, followed by a camera. We'll finish everything with a render top that will automatically allow us to preview and see this cube we're working on. Since I want to start seeing what I'm doing, I'm going to set up the post-processing network. For this, we'll use in screen space ambient occlusion, an RGB key operator to have a black background. We'll finally use an out top to visualize everything. As you know, we're working in this vertical resolution, so select the render top and set the resolution to 1080 by 1920. Finally, let's go back, add an out here and activate it. So we can now see this. Perfect. We have our grid, and finally, I'm going to bring in what I created earlier, and it's not my intention to show you this now because it's just a minor detail. Perfect. Let's start parametrizing these operators for the materials that we're going to use. Basically, the only thing I want to do is use these level operators by setting the step function because I want this to look like a topographic map. So I'll activate the step function and use the following parameters. This level operator here will be identical to the previous one, so we can delete it reconnecting as follows. Perfect. Now, we don't have to do anything else here. Let's move on to the next network for the 3D scene. Select the grid and copy the following parameters. Leave everything as it is, and in rows and columns, we'll increase it to 50 by 50. Next, in the attribute create, make sure to activate the normal and tangents, as this will allow us to use the displacement in the material. Finally, let's go to the geo operator. And I want to make a few simple changes because I want a more another view. So select the geo operator and apply a rotation of 90 here and minus 45. Perfect. In translate, I'll set it to 0.25. Now, as you can see, our surface is here, the one that will be displaced later. Now we'll use an HDRI here with the environment map. Finally, I'll zoom in a bit and adjust the position around here. We have our grid that will be transformed using a height map to achieve the displacement effect. And later we can play around with the lighting a bit. But for now, we can start with these parameters. Let's go to the light operator, set it to white, and increase the intensity to 20. In shadows, activate them. And we'll leave everything else as it is for now, because we want to see what happens here first, and then we'll recalibrate it. Finally, let's move on to ambient occlusion. You can use the same parameters as me, so copy these values. For now, we have almost everything ready, and now we'll reference the texture in the PBR material, and we should start seeing results. Select the first one, go to Map, and map the base color. Perfect. The emit map should now display something over here. Set the normal map here, activate the height map, and map the texture in the PBR material. Perfect. And let's activate the parallel occlusion and displacement as well. Now we can see we have this texture here. It doesn't show up fully yet because we still need to make some adjustments. But before we leave this section, we can use the following parameters. Here in the bump map, we'll use 100. And in displace, we'll leave it at 0.5 and displacement point at 1. Perfect. Now, if we go to the material operator, and honestly, It's a matter of preference how you want to use it, but the important thing is the emit map, because we want the color emitted by this texture to be the same color as the one we created. So in emit, practically, if we set it to white, it'll pick up all the color, and you can even see the black border we created earlier. So now we have this, and again, if the metallic setting, well, you can adjust it as you prefer. Finally, if we go to our noise top, you know that any parameter we change here will be reflected directly in this. I'm going to zoom in a bit with the camera to get a better view and also adjust the lighting. If you don't notice the lighting well, you can. A trick I like to use is to increase the dimmer significantly, which helps me see exactly where the lighting is hitting. This approach is interesting because it allows me to experiment with different lighting colors and reflections. Using screen space ambient occlusion adds much more depth and contrast to the shadows. Now comes the most interesting part of the noise top. We have an extremely simple node generating a displacement texture here. Now, we can start playing with the different parameters of the noise, doing simple things like changing the period, adjusting the animation time. For example, we could make it much faster, and we get much more interesting effects like this. The amplitude also helps us achieve something that looks more like water, and the exponent allows us to tweak the offset. And well, here you can start playing around with the values as you like, and also start using different types of noise. Remember that the simplex noise uses the GPU and doesn't consume as many resources. Depending on the type of noise you use, you'll notice your frame rate might vary. Great, I hope you've enjoyed learning how to use this noise technique to create a dynamic 3D displacement effect. Let's move on to the next part. Modern times. The concept of displacement mapping was first formalized by Robert L. Cook and William Max in 1981. Their work laid the groundwork for techniques that allowed artists to modify the geometry of 3D surfaces using texture maps, specifically height maps, to create detailed surface variations. This innovation was crucial because it allowed for the addition of complex details, such as bumps, ridges, and other surface irregularities, without the need to increase the number of polygons in the model. Chapter 5. Procedural Animation with Noise. Parametric animation with noise refers to a technique in computer graphics where the parameters controlling an animation are modulated or influenced by noise functions. This approach allows for the generation of movements and shape changes that are more organic, unpredictable, and less uniform compared to those created by linear interpolations or manual animations. Let's briefly review what I'm doing here to generate this parametric animation using noise. Basically, this entire new segment is the same, the rest continues, just as we left it previously. And the logic here is to be recursive. So I use the same noise, converting it into data to later apply it to this visualization. In this case, it could have been any of the three colors, because when we convert the noise data to colors, we get an RGBA, meaning red, green, blue, and alpha. What I do afterward, through various networks and operations, is to visualize this line. And finally, this line that you see here is the result. I used instances to generate several clones of the same line, and they are responding to the movement of the noise generated from this operator here. This means that if we move any parameter, this visualization, let's say, of the line will begin to adapt to whatever changes we make. So this is one way to generate animations. In this case, a line-based animation using the noise operator we are working with. Of course, there are simpler ways to achieve something like this. TouchDesigner also has a noise operator that already generates these kinds of movements without needing to extract them from a noise top. However, I find it interesting to see how recursive this can become, and that a single operator controls all the visual behaviors that will take place here. So I'm going to show you how I did all of this. Let's start by creating a top-to operator. You can drag the top operator you want and immediately insert it here, but there is another way to create it. Just like this, right-click on the noise operator, go to the chop menu, and select a top-to operator. This is another way of creating and ensuring you're connecting and transforming this image into data. Okay, perfect. So let's continue. We're going to use a select operator. From this select, we're going to connect to an analyze operator, because later on, we'll want to see the maximum and minimum values that we will have. Let's duplicate this analyze operator, and we'll rename them as max for maximum and min for minimum. Perfect. Now we create a math operator and connect it just like this. Now, The idea is to proceed with a resample operator because we want to do the following. Once I've created my line, this line will have points. Each of these points will be equivalent to a sample, and I need them to have the same number of samples for this to look good. After creating the sample, I will make a null operator I can call ty, and then I will right-click on the null and create a chop to. Then create a composite operator. I'm going to create a ramp and connect it to the composite as follows. From this composite operator, I'll create another top to. After the top to, rename operator. And finally, I will begin to create my 3D line. So I will call a line operator in the SOP section. And this line, we want to transform it into data channels because we want to mix it with the y-axis down here, which we will see shortly. So right-click and connect a SOP to. Perfect. We are also going to use a select operator and finally a merge operator. We'll place it further down and connect this last element directly here. So far, so good. We will finish this later by creating 3 more operators. But first, I want you to check the parameters before we move forward. Now, let's go back here. We go to the select operator, and what I really want is to use only one of the noise's colors as data. So I'm sticking with the red channel. Then I go to Analyze and select Maximum. Go to the analysis below and select Minimum, ensuring that we can see the maximum and minimum values for the next step. Now, I will map these values in the MAT operator as follows. With this, if we notice, the input values have now been normalized. Now select the line. This line currently only has 2 points, so I will increase it to 1,000 points. Then, in the sample operator, I will go to Common, Disable Time Slicing, go to Resample Options, and select New Rate, New Interval. We choose samples and set them from 0 to 1,000. Perfect. Now I have the same number of samples that I need. And in unit values, you will need to set them to absolute. As you can see, I have 1,000 samples, and here I have 1,000 points. Now go to the select operator. And in this case, I just want the x and z coordinates because we are creating the y coordinate further down here. Okay, we can see that we have this line, which is now represented in an image. And here, I want to explain an interesting concept, but I'll tell you later how we'll use a ramp to modify how this line looks in the overall network. Now, go to the composite operator. We will leave it in multiply mode. Now we go to top 2 and remove all the other channels because I only want the red channel. I go to rename and we'll call this channel TY. Now this channel is connected here in this merge. So now we have TX, TY, and TZ. And now this will draw the line we want to create. Right-click, select Soft, and choose Chop To. Now you will see that we already have a beautiful line generated here. But we have a problem. As you can see, this line is not displaying the results we want. The issue arises because we're using a composite that combines this ramp operator with the data coming from the noise. The ramp plays a crucial role here because the top 2at interprets the image values in a specific way. Black equals 0 and white equals 1. Now, if we temporarily set the ramp to all white so that it doesn't affect the original image coming from the noise, we can see the noise movement reflected in the line. However, there's another issue. The line's starting vertex also shifts position, which prevents us from achieving the effect we want. Here's where the trick with the ramp comes into play. We will use the ramp to apply black color at both the left and right ends of the line. This means that when we use black at both extremes, they will always stay anchored at 0. This way, we can make the rest of the line undulate while keeping the ends static. This technique allows us to control the movement of the line, ensuring that the middle section moves according to the noise, while the ends remain fixed, creating the visual effect we're aiming for. This is what will generate the animation of the line. If you notice, these points stayed at 0. This gives me a much more interesting line for what I want to use. If I change the noise, for example, if I modify the period parameter of the noise, I will begin to see this animation reflected here. So this is extremely interesting. Now, I want to see this in my composition. Therefore, we need to create a geo operator. Right-click here, add a geo. We just need to move it, adjust the coordinates to position it correctly. But aside from that, I'm going to create the clones from this operator. So create a select operator here, placing it further down. Next, I will create another resample, and finally, I will add a math operator. In the select operator, select only TX. We will do the same as before. Remove time slice, set it to same rate, new interval, and set it to absolute, from 0 to 50. This is the number of clones I want. And in the math operator, I will set the range from 0 to 1. Let's increase this from 0 to 20, because I want a greater distance between the clones. So the only thing left to do is rename this math operator to clones, now to geo instances, enable the instances, and reference this in the translate. For translate deep, select TX coordinates. I forgot to set the samples here, so it's currently in seconds. I'll set it to samples, and now if I input 20, go to the math, and set the range from 0 to 1, and maybe from 0 to 20, I can increase the number of samples by hand. For example, let's set it to 50 samples, and in the math operator, I'll adjust it to go from 0 to 1 and from 0 to 5. Now I have something much closer to what I need. I'm at 50 now, which is perfect. I can continue testing here with my mouse to evaluate how I want this to look. For instance, if I want each of these lines to match a point in this mesh, I can manually adjust the values until they fit. Finally, I can remove this face here. I believe it's this one. Let me check. Okay, and done. So, we've finished this part. Now, when we go back to the noise, here's the most interesting part. If, for example, I start playing with the harmonics, I can see a reflection of the noise happening in the lines. Obviously, this technique can be applied to a lot of other things, but I think this is an interesting enough example to realize what the applications of using noise for animation generation are. Okay, let's move on to the next section. Chapter 6, Simulating Natural Phenomena. All right, we've reached the end of TouchDesigner 101, and I've put together a project file that contains everything we've worked on so far. Additionally, I've added a few components, including simulations for water, fire, and skies. You can find this project on my Patreon, and I encourage you to check it out. Take your time to dissect each component and explore how they work. By doing so, you'll get a more intuitive understanding of what's happening, and you'll be able to review some of the concepts we've covered. So, how does it work? Once inside, you can select the type of composition. First, there's the simple 2D noise texture, which was the first thing we created. Then, we explored displacement noise with 3D surfaces, which is the second composition in the file. If you followed along with the tutorial, you should already be familiar with it. After that, we have parametric animation. Now, for the water simulation, you can dive into the base component, and you'll see that it's the same displacement technique we discussed earlier. I've also added some extra components, like an edge filter, to enhance the effect. Moving on to the fire simulation, this is primarily driven by noise as well, but I'm using different techniques here, mostly post-processing effects, followed by several layers of displacement. It would be really interesting for you to explore this project and start thinking about other ways you can apply noise to your own projects. Finally, there's the cloud simulation, which is more synthetic and abstract. These clouds are quite unique, but I find them fascinating. As I mentioned at the beginning of this video, TouchDesigner isn't necessarily about mimicking hyper-realistic effects. It's also a tool for experimenting with more abstract, artistic languages. In this project, I'm using a custom component called pseudo-liquid. I have a separate video showing you how to create this component, but you can also find its latest, more advanced version on my Patreon. It would be great if you could take a look at this project file. Remember, it's available on my Patreon, along with some small sound design elements I've included to add more depth and immersion to what we're visualizing. I hope you've enjoyed the tutorial so far. As always, I love creating this content for you, and I look forward to seeing you in the next videos. See you soon.